In this example, we're asked to find the area outside the cordioid and inside the circle. Outside the cordioid, inside the circle. So again, I want you to draw the picture on your paper, pause the video, and shade in the region that we are talking about. Then come back. So hopefully you have shaded in the area that I have outlined in light blue. Outside of the cordioid, but still inside the circle. How are we going to find that area? I want you to think about it. Would we add two things? Could we subtract? Could we just find the area as is? Think about it, write down a plan, and let's see if we match. Well, what I think we need to do is maybe find the area of half of the circle, which we can certainly do without calculus, and then we could find the area of this part of the cordioid and subtract it. Okay, so if I find the area of the half of the circle and subtract the shaded region of the cordioid, I think that would give me the answer I am looking for. Does that sound like a reasonable attack? Convince yourself. Can we find the area of half of a circle? Sure. Okay, so what's the area of a circle? It's pi r squared. So r is 1, and I want half of it. So that would be 1/2 pi. So that's the area of that half of a circle. But now I've got to figure out, how do you find the area of that part of the cordioid? Well, I think what I want to do is I just want to find this top part and then multiply by 2, and that would give me the shaded region of the cordioid. So I'm going to say, well, my area is 2 because I have the top half and the bottom half, times 1/2. R is using the cordioid, squared d theta. And once again, I'm faced with, what are my limits of integration? I want to go from this point up to this point. How does that cordioid trace out? Well, on the last example, we set the cordioid equal to 0 to see what that point was, and then we set the cordioid equal to 1 because that would be the radius of the circle, and we found out what theta is here. So here, r is 0. What is theta? I want you to work on that and then come back. You should have verified that theta is 0 here and it's pi over 2 there. Really just like the picture looks like, but you still need to verify that, either on a graphing calculator or with algebra. So I want to go from 0 to pi over 2. And remember, this is the region that I've shaded of the cordioid, and I need to subtract it from the area of the circle. So once again, FOIL this out. Use your identity. And let's see, remember, this is going to be 1/2 plus that 1, that's going to be 3/2. And then I have cosine 2 theta also divided by 2, so you could say plus 1/2. Remember, dividing by 2 is just the same as a half. Okay, so integrating that, that's 3/2 theta minus 2 sine theta plus 1/2. And then again, because of that 2, I need to divide by 2 again. And I want to evaluate between 0 and pi over 2. So let's see, that's 3/2 times pi over 2 minus 2 times the sine of pi over 2, which is 1, plus 1/4, that makes 1/4. And then 2 times pi over 2 is pi, and the sine of pi is 0. So that's the top limit. Then I need to subtract. I need to put in 0 everywhere. So I have 3/2 times 0 minus 2 times the sine of 0 plus 1/4 times the sine of 0. So again, all of that is 0. That's 0. This is not. So what do I have here? This is going to be 3 pi over 4 minus 2. Now remember, that's the area of the cordioid. Let's look back up here. So I have to take the area of my circle, so that's the area of my circle, and subtract the area of the cordioid. Okay, so I should have a negative and a negative, that's a positive 2. A 1/2 pi minus 3/4 pi is going to be pi over 4. So this is going to be my total answer. Again, the hard part is figuring out what area you want, what are your limits of integration, are you adding, are you subtracting, what are you doing for each problem. Now this one is a bit harder. Okay, so I have the initial picture, and then what I did is I zoomed in on the part that we really need to look at. So it just says to set up the integral. We're not going to go through and integrate it because the setting up is really the harder part, and that's the part you need to practice. So let's see, we want the area shared by the cordioid and the circle. What do they have in common? So you might want to look at the little picture. Again, look at it, put it on your paper, color in, shade that area that is overlapping between the cordioid and the circle. You should have done this part right there. And again, you should also notice that's symmetrical. Okay, so looking at the bigger blown up region, do you see anything that you can just use geometry? Well, hopefully you can. Hopefully you see that this is just part of a circle, a half of a circle. And then, of course, you have that little region, and you're going, oh, but we've already done that. No, that's what makes this harder, is because before, this point right there was up on an axis. So we need to split this region into two pieces, because as we're taking that area, as I'm sweeping out from the pole and drawing my sectors, until I get to this point right here, this angle right here, I'm along the cordioid. Then as I keep going over here, that is along the circle. So I really have another part of the circle here, and then the cordioid. We've got to figure out, what are my limits? How am I going to do that? Well, let's do the easy part first. How about this half of a circle? So I need a half of the circle. That would give me the top part. Then I need 2 more sectors of that circle. Okay, plus 2 sectors of a circle. Then I need plus 2 of those parts. So I'm going to say plus 2 of the red regions. Okay, so without calculus, I can find the area of a half of a circle. So half of a radius of 1, that's just going to be, let's see, that half of the circle would just be 1/2 pi. 1/2 pi r squared, and r is 1. So I've got to find the sectors, and then I've got to find here. So really what it comes down to, again, are what are my limits of integration. So I need to know, when is it there and there. So when does r equal to 0? So I'm going to set this equal to 0. And then on this point, I need to know really when they intersect. When does the circle and the cardioid intersect? Or in other words, when does the radius equal to 1? So again, why don't you pause the video and solve those equations for theta? Okay, so how'd you do? When does sine theta equal to -1? Theta should equal to 3 pi over 2. We did that on the last example. When does the sine of theta equal to -1/2? And it makes sense. It's in quadrants 3 and 4. So quadrant 3, quadrant 4. What are those values? Theta should be 7 pi over 6 and 11 pi over 6. Okay, so I think we have some values. That's good. So this point right here at the pole, r is 0 and theta is 3 pi over 2. This point right here, r is 1 and theta is 11 pi over 6. And this point over here is when theta is 7 pi over 6. So let's write down what we know. How do we find the area of the circle? The blue part. What can I do? Well, so the two sectors of the circle, I could do 2 times 1/2. Well, the circle, that's r. What was r equal to? Well, that's just 1 squared d theta, but what would be my limits? Well, you could choose some different ones, but I'm going to go from 11 pi over 6 up to 2 pi. And I'm multiplying by 2 because I have 2 blue parts. Well, that's pretty easy. You integrate 1, you just get theta. So that's just going to be theta between 11 pi over 6 and 2 pi. So what are we going to have? We're going to have 2 pi minus 11 pi over 6, which is just pi over 6. Okay, so I've got my area of the half of the circle. I've got the area of the 2 blue parts of the circle. Now I've got to find the regions using the cardioid. Okay, so the 2 red regions. The area would be 2 because I have 2 of them, 1/2, and I'm using the cardioid, which is 1 plus sine theta squared d theta. So again, I would reduce that, square that all out, and add up all 3 answers. So again, the half the circle plus the sectors of the circle plus the integral of 1 plus sine theta squared d theta. Ooh, but what have we forgotten? What are my limits? Well, let's see. Coming back here, I could go from 3 pi over 2, that would be the pole, sweeping out to 11 pi over 6. So 3 pi over 2 to 11 pi over 6, and that would get me that answer. If you want to work it out and ask me what the answer is in class, I'll verify it for you.